Good afternoon and welcome to this press briefing for the European State of the Climate Report 2022 produced by the Copernicus Climate Change Service and the European Centre for Medium Range Weather Forecasts. My name is Dr. Samantha Burgess and I'm the Deputy Director of the Copernicus Climate Change Service, and I will be the moderator for the first part of the briefing. The format of today's briefing will include two short interventions by the European Commission's Directorate General of Defence, Industry and Space and the Director of C3S before a presentation of the key findings of the report from the lead editor of the report, Dr. Rebecca Emerton, followed by a panel discussion where you will have the opportunity to ask questions about the report's key findings. We have a housekeeping slide, so please note that this press briefing is recorded, and please include your name and affiliation when you ask your questions in the chat. I think everyone is now more than comfortable with Zoom, so it will proceed as any other Zoom webinar. I now have a great pleasure to introduce Dr. Mauro Facchini, Head of Earth Observation at the Directorate General for Defence, Industry and Space, European Commission. Over to you, Mauro.
Thank you very much, Sam. Good afternoon to everyone. Thank you for the invitation. It's a pleasure to be here at this event. It's becoming a kind of a routine. I think now, I think this European State of the Climate for 2022, if I'm not wrong, it's already the 6th annual report. If I'm wrong, I'm sure that someone will correct me. But I think in any case, it's extremely important. Why is it important? We think that only policies that are based on accurate information and data on the current state of the climate can really help achieving climate goals that we have established as citizens, but also established as policymakers. The European State of the Climate Report is an essential tool to help the European Union, and not only about the climate adaptation agenda, and to reach climate neutrality by 2050. We have seen, we have all witnessed that in the last period, that the global warming is even more frequent, and we have more and more extreme events happening in Europe, but I think all over the world it is the case. Every one of us can really witness that. Indeed, there are reports, IPCC reports and so on, but I think that every one of us just turning on the TV channels and looking at what's happening can see what are really the effects of climate change. We have seen the extent of heat waves over summer, but also extending beyond summer, droughts that are more and more evident in several regions, record loss of glaciers in the Alps, impact on energy production that actually it has also to be increased. And we see that these impacts are longer, so they occupy most of the year, and at the same time they're also more frequent. For example, if we look at weather events, extreme weather events, even those ones are extremely frequent at this moment in time. We really need at this moment in time to look on how we can introduce some adaptation policies and mitigation measures, policies in order to really adapt to what is happening. So the scarcity of water is an example, how really to look on the amount of water, how to make the priority on the use of that, and how to make to save the use of water for the future, or create new ways of storing it. And at the same time, we have to look at mitigation, so in particular linked to the greenhouse gas emissions that are continuously increasing, and how we can try to reduce it and to mitigate it. In that respect, we are putting a lot of emphasis in the observation of CO2. Copernicus is planning to have a new CO2 observation system in place in the next 2-3 years. In order really to monitor in some way what is the extent of anthropogenic emission, but at the same time to observe and to analyze what is the real effect of measures and policies that are put in place to reduce emissions. So I would say that for the climate mitigation and adaptation, our ambition in Copernicus is to provide the best data and the right information to inform and guide the policy making and policy implementation to maximize policy effectiveness and efficiency. I will not take more with my general introduction, because I think that the key element of today is really the presentation of the report with the key findings that are every year extremely interesting, frightening, I have to say, in some way, but I think we have to know the truth if we want to react in an appropriate manner. So thank you very much for the invitation, and I really wish you a good continuation for today, for this event. Thank you very much.
Thank you, Mauro, for those very insightful words. I would now like to introduce Dr. Carlo Bontempo, Director of the Copernicus Climate Change Service, to give a short intervention.
Thank you, Sam, and thank you, Mauro, for your introductory words. And good afternoon to all of you. Thank you for joining us today for this media briefing on the European State of the Climate 2022. The report, which, as Mauro mentioned, has become a regular appointment for many of us, summarizes the latest finding and the data related to the climate situation in Europe, and put those data in the context of a global changing climate. As you are all very well aware, the climate crisis has become a major concern for the entire world, with serious consequences on our planet's ecosystem, economies, and society. The State of the Climate report, which has been prepared by a team of expert scientists, presented a detailed analysis of the current climate situation in Europe and provides a direct link to the climate data that, thanks to the Copernicus program, is open and freely available for anyone to use and scrutinize. The report highlights some concerning trends, with 2022 being yet another record-breaking year in terms of greenhouse gases concentration, in terms of temperature extremes, wildfire, and precipitation, which have all had noticeable impact on both ecosystem and community all over the continent. As journalists, you play a crucial role in informing and educating the public on our changing climate and the impact this is having on our human activities. The climate all of us will live in will be different from the climate of our youth. The environmental challenges our sons and daughters will face will be different from those faced by us or by our parents and grandparents. We are really moving into an uncharted territory where our collective experience will be less useful than it was even only a few decades ago. In this new world, using wisely the information we have about the world around us will inevitably become more important. I'm convinced that the information presented in this report will be useful to you in your work, and you will be able to communicate to your audience in an accurate and effective manner. And the many unprecedented events we listed in the report will certainly provide food for thoughts, as well as good material for headlines. But if you have the opportunity, I would like for you to consider also another element of the report, which is its traceability to high-quality observational and model data. Collectively, we'll need to get better at taking advantage of our understanding of the climate system, as our ability to thrive, and in some cases, our own livelihoods, depends also on this. You can play a role in ensuring that people look up and deal with the facts of our changing climate. Before concluding, I would like to express my most sincere gratitude to the team of scientists who have contributed to this report, not only within ECMWF, but also within the many organizations and institutions that have supported this important piece of work. In conclusion, our climate is changing. We do understand the drivers behind the observed changes, and we must work together to reduce greenhouse gases emission, to adapt to a changing climate, and to build resilience in vulnerable communities. Let's take this report as yet another wake-up call to accelerate our efforts and make a positive impact on our planet's future. Thank you again for joining us today. Over to you, Sam.
Thank you, Carlo. For those who have joined us at previous press briefings, we have a new lead editor for the report this year, and I'm delighted to introduce Dr. Rebecca Emerton, scientist at ECMWF and lead editor for the European State of the Climate 2022. Over to you, Rebecca. Please share your screen when you are ready.
Thank you, Samantha. And welcome everyone. So we know, and we've heard already today, that our climate is changing. Greenhouse gases are increasing and temperatures are rising. Today, I'm going to take you through some of the key findings from the European State of the Climate, which provides a detailed analysis of the evolution of our climate during 2022 and the key events of the year, based, as we've already heard today, on state-of-the-art datasets. This report is the 6th edition of its kind, and every year we cover more and more of what Copernicus can provide in terms of Earth system monitoring. I'd like to start just by thanking the editorial team for this report, Julian Nicholas, Francesca Guglielmo, and David Lavers, as well as Samantha Burgess and Annabelle Cook, and all of the many fantastic scientists and colleagues at Copernicus and ECMWF across Europe and around the world who have contributed to this report this year. So here I've shown a snapshot of some of the key climate indicators that we show on our climate dashboard and that we update every year alongside the European State of the Climate. So greenhouse gases continue to increase, and as we know, this continual increase is driving the increasing temperatures, which are now estimated to have reached around 1.2 degrees above pre-industrial levels, so the latter half of the 19th century globally. In Europe, this increase is even larger, at around 2.2 degrees above pre-industrial levels, and the Arctic is warming faster than the rest of the globe, now at an estimated around 3 degrees above pre-industrial levels. But while greenhouse gases and temperatures are two incredibly important climate indicators, there are many other important aspects of our Earth system that we also monitor. And this includes sea surface temperatures, which continue to increase, although the last year was the 6th warmest on record, marking the 3rd year in a row with La Niña conditions present, meaning it was cooler than some other recent years. Glaciers around the world have continued to lose ice mass. Sea ice extent in the Arctic has declined in recent decades, and Antarctic sea ice extent reaching its lowest minimum extent on record successively in both 2022 and already in 2023. The ice sheets also continue to lose ice mass, and since the 1970s, the Greenland and Antarctic ice sheets together have lost more than 11,000 cubic kilometers of ice. And while it's of course hugely important to monitor the global climate, it's also important to understand changes in the climate at more regional levels and the implications and impacts of these changes. So last year, we reported quite a contrast in temperatures in Europe during 2021, but in 2022, the year was really characterized by many more warm events than cool events. The year as a whole for Europe was the 2nd warmest on record at 0.9 degrees above the recent 1991 to 2020 reference period. But for many countries in the west and southwest of Europe, it was the warmest year on record. Europe also saw its warmest summer on record by a large margin at 1.4 degrees above average. And when I say average, I'm referring to the recent 1991 to 2020 reference period. But it also exceeded the previous warmest summer, which was only in 2021, by 0.3 to 0.4 degrees, which is again quite a large margin. And not only the land, but also the sea surface was generally warmer than average. Across Europe's seas, the average sea surface temperature was the warmest on record, and the Western Mediterranean Sea saw large anomalies from May onwards, with record-breaking marine heat waves throughout the summer, and in other regions too at different times of the year. So I've mentioned the marine heat waves and hinted at some of these records, but I'm sure many of us remember that last year in Europe, we experienced many and varied extreme events. And here we've picked out not all of them, but some of the key events that affected wide areas of Europe and many countries, and some of the records that were broken last year. So some of these I'll go into in a bit more detail shortly, but as I mentioned, Europe saw its warmest summer on record, which also brought a number of widespread and extreme heat waves and contributed to the widespread and prolonged drought that we saw last year. We had a record loss of glacier ice in the Alps, record sunshine duration, the 2nd lowest average river flow on record, and the 2nd largest wildfire burned area on record in the EU countries. And while the hot and dry conditions somewhat dominated, it was not the entire picture, and parts of Europe also saw flooding from intense rainfall. In February, we had 3 storms in the space of 1 week impacting northwestern Europe, and with quite significant impacts, and some areas also saw unusual cold conditions during certain periods of the year. But to look in a bit more detail at some of these key events, it would be hard to give an overview of last year without discussing the extreme heat. So while summer was the warmest on record, Europe saw unseasonably warm temperatures in varying regions throughout the year. In March, from May through to August, in October and in December. In July, temperatures reached 40 degrees for the first time ever in the UK. And we see that globally, increasingly high latitudes are seeing more extreme temperatures, including those exceeding 40 degrees. In summer, the heat waves led to a record number of days with very strong heat stress in southern Europe, where heat stress is a measure of how the environment impacts on the human body. So as well as accounting for temperature, it takes into consideration other aspects of the environment, such as the humidity, the wind speed, and also how the body actually reacts to its environment. So overall, we're seeing an increase in the number of summer days with this very strong heat stress across Europe. And in southern Europe, also an increase in the number of days with extreme heat stress. This means that the number of days in summer where we don't experience any heat stress is also decreasing. And alongside heat stress itself, other dangers from the heat waves that we saw last year included the contribution to the spread and intensification of wildfires. And as I mentioned just now, the EU countries saw their second largest burnt area on record from wildfires. The high temperatures and the long sunshine hours also contributed to the surface ozone concentrations, reaching potentially harmful levels across much of Europe. Another key event that we've looked at in detail in the European State of the Climate report this year is the widespread and prolonged drought that most of Europe faced last year, as a result of the lower than average precipitation and higher than average temperatures, with exceptional heat waves. Less precipitation than average was seen for a long period last year, from January through to August, and one of the worst affected areas was the Italian Alps, which saw spring snowfall as much as 60% below average, and we'll come back to this again in just a minute. But as part of this situation, the soil moisture conditions for the year as a whole for Europe were the second driest in the last 50 years. Average river flows were the second lowest on record, but in terms of the area affected, it was the driest year on record, with 63% of Europe's rivers seeing below average river flow, which I think really highlights just how widespread this event was. And of course, these conditions not only impacted natural systems, but had impacts on society, affecting sectors such as agriculture, energy, and river transport. And I mentioned that I would come back to this information about the snow deficit in the Alps, which was one of the areas that was worst affected by the below average precipitation. And this relates to another huge impact of the conditions of last year, which is that the below average snowfall in the winter of 2021 into 2022 and in spring 2022 across much of Europe, but in particular the Alps, and combined with the exceptionally warm temperatures, this lack of snow and below average precipitation led to a record loss of ice from the glaciers in the European Alps. This loss of ice is equivalent to around 5 cubic kilometers of ice. So to try and visualize that, if you were to make an ice cube with 5 cubic kilometers of ice, it would look a bit like this, towering over Paris at 5.4 times the height of the Eiffel Tower. So now stepping back from the extreme events, I wanted to highlight that in this year's report, we also looked at the potential power generation from 2 renewable energy sources across Europe last year, wind power and solar photovoltaic power. It is important to note here that our analysis only takes into account the influence of the climate conditions on power generation, and we don't look at other factors at the moment, such as growth in power generation capacity across Europe. So we found that potential power generation from onshore wind was below average across most of Europe last year, especially in southern central regions, while potential solar voltaic power generation was above average in most of Europe. This is linked to the conditions we saw last year with below average wind speeds in large parts of Western, Central and Northeastern Europe, and above average wind speeds in Southeastern Europe and parts of Spain. 2022 also saw the highest amount of surface solar radiation in the 40-year satellite record. And while we don't see a clear trend in annual average wind speeds across Europe, we do see a clear increase in surface solar radiation. Another aspect we discuss in the report is climate-driven electricity demand. And again, with this analysis, it's important to note that this is not reporting the actual electricity demand, but shows how the demand was influenced by the climate last year. So this climate-driven demand was below average in most areas of Europe, and this was linked to the above average temperatures in the non-summer months, leading to a reduced demand for heating. In southern Europe, the demand was above average, mainly as a result of the high summer temperatures and a correspondingly higher demand for air conditioning. So I've been talking a lot about Europe, but we also look at the Arctic in the report. And as I mentioned earlier, we know that the Arctic has warmed by around 3 degrees since the pre-industrial era. So 2022 was the 6th warmest year on record for the Arctic and the 4th warmest year on record for Arctic land. And for the year as a whole, much of the northern high latitudes experienced above average temperatures, except for parts of Canada and Alaska. In the Svalbard region, summer was the warmest on record, and Greenland also experienced a period of heat waves, which I'll come back to shortly. In terms of wildfires, last year saw close to average wildfire activity and carbon emission from wildfires. In previous years, much of the wildfire activity in the Arctic was concentrated in Siberia, but in 2022, most activity was actually from Alaska and Canada's Northwest and Yukon territories. In terms of carbon emissions from wildfires, the estimated emissions from the Arctic reached around 9 million tonnes, which is less than the 15 million tonnes last year and much less than the 58 million tonnes in 2020. Sea ice is, of course, an important part of the Arctic's climate, and in 2022, it remained consistently below, but close to average for the Arctic as a whole. In the Barents Sea, however, the sea ice extent dropped rapidly in late May and early June to near record low levels and reaching near zero at the end of July. And this was due to warm southerly winds over the area. The Barents and Kara Seas also saw well above average sea surface temperatures during the summer, which likely delayed the development of sea ice cover in the autumn. And I mentioned I would come back to the heat waves in Greenland, which were really quite exceptional. And so we have a spotlight section on this key event too. So during September last year, Greenland experienced this exceptional heat and large amounts of rainfall as a result of a series of atmospheric rivers, which you can see an example of in this animation. So atmospheric rivers are these long, narrow bands of concentrated moisture transport in the atmosphere, and they can bring precipitation and flooding when they reach land. And in Greenland's case, they brought a lot of moisture and temperatures that were up to 8 degrees above average for the month as a whole, meaning that there was a lot of rainfall at a time of year where snow would be more typical, leading to unprecedented levels of ice sheet melt for the time of year, where almost a quarter of the ice sheet was under surface melt at the peak of the first heat wave. And we go into more detail about this event in the report, but it's also been shown in the literature that the frequency of atmospheric rivers reaching Greenland has increased since the 1990s, contributing further to ice sheet melt. And so finally, while I've talked today about many records that were broken, how many different aspects of our climate looked and evolved over the last year, and with a detailed look at the drought and heat waves in Europe and in Greenland, I of course couldn't give this presentation without mentioning a driving factor of all of these changes, the increase in greenhouse gases. The greenhouse gases, of course, continued to increase and reach record levels in 2022, and they will continue to do so unless we make important reductions in our greenhouse gas emissions. So with that, thank you very much, everyone.
Thank you. Thank you very much, Rebecca. That's been an excellent summary of the report. We're experiencing at the moment some minor technical glitches with Samantha momentarily disappearing from the link, but I see her connected again, so I can possibly pass it over to her.
Apologies for my connection failures today. It's immensely frustrating. I completely missed the question that you asked, Carlos. If you could repeat it, please.
No, I was just acknowledging the fact that there were technical glitches and giving you the floor. But given that we are moving anyway towards the Q&A session, maybe we can just go straight into it. I've seen many questions coming into the chat, and many more will come later. So for this interactive Q&A, we have a small panel. So Samantha Burgess, that you have already seen, Deputy Director of the Copernicus Climate Change Service, and Vincent Henri-Peuc, who's the Director of the Copernicus Atmospheric Monitoring Service. And possibly is another small technical glitch. Oh no, now is all aligned. So I was saying we have a long list of questions, and I will go through all of them, try not to distort too badly the name of the journalist asking the question. So the first question, I believe, is from Carl Hellström from the Swedish Public Service Television. And it's a question about the record heat last summer and the number of days with heat stress how is this connected to human-induced climate change? And what does the future looks like regarding heat in Southern Europe? 50 degrees? Sam, over to you.
Thank you, Carlo. So one of the most important things to bear in mind is that the weather varies, and the consequences of climate change amplify some of that variability in weather. So wherever you are in the world, some years will be hotter, some will be cooler, but the chances of warmer years is increasing all the time. So if you can imagine having a deck of cards and picking one at random, red is the warm year, black is cool, climate change is removing the black cards from the deck and adding extra red ones. So we can say with confidence that in 2022, European citizens were under more heat stress than they've ever been under before because of the warmer summer in record in 2022. We can't say that there will be more heat stress again in 2023, but it is likely with higher concentrations of greenhouse gases in the atmosphere, the probability of more warm years continues to increase.
Thank you, Sam. From what I've seen, it won't be the last question coming your way. There is quite a few questions covering this element of the report, but later on, Vincent, don't worry that there will be questions coming your way as well. So stay warm there. So the next question is from the Standard in Brussels. It's from Tom Jesselberg, and is about the record number of days with heat stress in Southern Europe. Can you give as a number and country region? Is the number of consecutive days also of interest exceptional?
So in terms of heat stress in particular, we have some supporting graphics in the report that look at both extreme heat stress, strong heat stress, and moderate heat stress, and these have different degree ranges. So we can say with confidence that the southern European countries, so the Mediterranean countries, received a significant amount of heat stress, coming up to 70 to 100 days where heat stress was experienced in some of those regions in southern Europe. Obviously, when we have heat waves vary in both their intensity and in their length of time. And the longer a heat wave is persistent for, the more likely there is amplification of those heat stress impacts.
Thank you, Sam. The next question is from Anne-Laure Fremont from Figaro, and it's why is Europe warming up faster than any other continent? There is also a second part of the question, and it's about what to expect in 2023 with potential return of El Niño. So maybe I can take the second part of the question and then I'll pass you the first one, Sam. We do expect, so the multi-seasonal prediction of CTS that is composed on a number of models expect a return to El Niño condition by the latter part of the summer. And there is a chance we'll get a strong El Niño towards the latter part of the year. Now, when we see El Niño, which is, as you know, the positive phase of the oscillation in the sea surface temperature in the Pacific, when we see El Niño, we tend to see peaks in the global mean temperature. So at the global level, El Niño is normally associated with record-breaking temperature on the global level. Whether this will happen in 2023 or in 2024 is not yet known, but is, I think, more likely than not, we will see another peak over the next 12 to 24 months. Then I can pass back to you, Sam, for the first part of the question.
Thank you. So in terms of what we've seen already over the last few months, winter and spring has been warmer than average in large parts, and it's also been drier than average. So this has obviously implications for water availability going into the growing season. So we've already seen some reports of water stress in Mediterranean countries, in Spain in particular. And unless we have significant precipitation recharge, so significant spring rainfall, the probability that there will be below average water availability in southern European countries over the spring and summer is likely to continue.
Thank you, Sam. The next question is from Thomas Jazravi from Global Need. Can you say anything about 2023 based on the condition this winter? I'm thinking about precipitation in the glacier. Should be worried about drought and now the low level in rivers, and also about the cycle of La Nina ending and the possible La Nina condition. I think the second part of the question has been addressed, and also part of the first, but maybe you want to add something more, Sam.
Thank you. So in terms of the water availability and the implications that we saw last year, it was a record amount of ice loss, mass loss from glaciers across Europe, particularly in the alpine regions across the Alpine Arc. So there was a small mass increase in glaciers in Scandinavia, but as Rebecca highlighted in the presentation, the amount of mass loss from European glaciers in the European Alps was the equivalent of 5 kilometers cubed, or an ice cube sitting in central Paris about 5.5 times the height of the Eiffel Tower. Obviously, this mass loss has major implications for hydropower and for water resources that rely on high snowfall and spring melt from these alpine regions. Obviously, water is a finite resource, and we as society haven't perhaps been as effective as possible in managing this finite resource. And I think the conditions both last year and looking at the longer term trends, where we see the last 6 years, there's been below average river discharge across the majority of European rivers, really means we need to adapt to the existing climate conditions where we are seeing less water availability than we have in the past.
Thank you, Sam. The next question is from Antonia Zimmerman from Politico, and again is about the drought condition. What can we expect in terms of drought in Europe this year, coming out of a particularly dry winter? What difference would a wet May make? And how can we expect the drought situation to develop in the coming years? So I think we cover most of the question already, but maybe we can add something in relation to the projection and how the projections are predicting the content.
Of course. So the projections and the scientific certainty is incredibly high that with a continued climate change scenario, the Mediterranean countries in particular will continue to have drought-like conditions in spring and summer. The divergence that we're seeing is that there isn't scientific certainty on drought conditions in Mediterranean countries in winter, which is obviously what we've experienced this year. If we did have a wet May, it would improve the situation significantly. At the moment, what we're seeing in terms of the soil moisture maps is the soils across the Mediterranean countries, the southern European countries, are incredibly dry. And if we do get a lot of moisture back into those soils from a very wet May and early summer, then that will benefit standing reservoirs and water availability for society. But unfortunately, the impacts are probably already in place for growing seasons. So we're likely to see reduced crop production this year because of the dry winter and spring period.
Thank you, Sam. And this also goes in the direction of the next question. Unsurprisingly, there is a lot of interest for the situation of the hydrology and the drought in Europe. The next question is from Enza Tedesco of Montel News. Following from the previous question, if we could elaborate further on the current hydro situation, particularly in Spain and Italy, which are already showing signs of distress. Is a repeat of 2022 condition possible? And maybe I can start here and then pass it to you, Sam, because in some respects, the situation is quite severe already, because depending on the part of Europe you look at, we may have missed the recharge window. So depending on the region, there are specific recharge periods. In some parts of Spain, there is clearly a peak in the early spring or early winter. And having had a deficit in that window, then we are in worse condition. Also, the snowpack that Sam was referring to is clearly depriving the water resources of a significant amount of water that is currently accumulated, or that could have been accumulated in form of snow. So for some region of Europe, the conditions are not dissimilar, and in some cases even worse than those that characterize the same period of previous year. I don't know if you want to elaborate further, Sam.
No, I think that was a very comprehensive answer.
Thank you. So then we can move on. I think the next question is from Padraig O'Ari from the Irish Examiner. Does historical Copernicus data suggest that the return of El Niño later this year will exacerbate extreme temperature and overall warmth in Europe in the coming years? Maybe I take this one, Sam. In terms of El Niño predictions, as I was mentioning before, most centers expect, well, basically all centers expect the return of El Niño by the middle part of the summer, with a prevalence of El Niño and possibly stronger El Niño in the last part of the year. This is associated with extreme temperature at the global level. The connection with the temperature in Europe is less strong, so it's not a direct link, the fact that having an El Niño will see high or extreme temperature in Europe. That said, there is a climate change signal, and we are seeing the climate change signal also in the seasonal prediction, with warmer than usual summer becoming more likely, just because in general the climate is getting warmer. So the next question is from Camilla Réchir from La Croix. Can you detail what strong, very strong and extreme heat stress means in terms of temperature ranges? Sam?
Yes, so strong heat stress range is feels like temperature of 32 to 38 degrees. Very strong is 38 to 46 degrees, and extreme is above 46 degrees. So these aren't just about temperatures, but also account for many aspects of the environment. But giving a sort of feels like temperature is one of the best mechanisms to enable people to appreciate how to correlate heat stress with what we've experienced.
Thank you. The next question is from Martin Koolmans from Volkskrant in the Netherlands. Is the lesser than average precipitation climate driven, and by which mechanism? After all, a warmer air would hold more moisture and lead to more precipitation. Tom?
Sorry, could you repeat the question again, please?
Yeah, so this is about the climate driver for below average precipitation. In a sense, the thermodynamical argument that with higher temperature, the atmosphere will hold more moisture, will go in the opposite direction. So what is the mechanism, if there is one, justifying the drying trend that we have seen last year?
Okay, so the drying trend that we saw last year is primarily due to the anticyclonic atmospheric circulation that we saw in the first 6 months of the year. So it's true what was stated in the question, that as the atmosphere warms, it has the ability to hold more moisture. However, where and when this moisture falls is obviously dependent on the atmospheric circulation and the conditions that enable the convective movement of clouds. And I think what we can say is, as the planet is warming, the normal climate that we're experiencing is shifting. So the chance of snowless mountains and lower rainfall increases. Not every year will we have such a hot spell that we had last year and the warm winter that we've seen over the past year. But we do expect drier summers in Southern Europe as global temperatures increase. Along with warmer temperatures, these bring higher risks of wildfire conditions. We cannot stop these impacts, but we can only limit the changes that these impacts have by reducing greenhouse gas emissions rapidly.
Thank you. So the next question is about whether the recording will be available today before the embargo. Indeed, that's the case. And so that was from Insight Online. We'll make the recording available. The next question is from Scott Dance at the Washington Post, and it's for Vincent Henry. Can you explain what is driving the increase in solar radiation?
Yes, there are two main factors. The main one is probably the anomaly in terms of cloudiness, which is driving this increased solar radiation. The other factor, which is less, is the changes in the aerosol loading of the atmosphere. But one has to also consider that the amount of radiation that reaches the ground is not the only factor to take into account. First of all, there is the installed capacity in terms of photovoltaic equipment, which is important. And also when solar radiation is intense, but temperatures are also very high, the efficiency of photovoltaic cell may be limited. So it's a mix. The key driver is the cloud conditions, but the specificities of the equipment also make a difference in terms of energy that is produced in them.
And maybe we can, I know I'm not following the time sequence of the question, but there is a question from Larissa Schwedes, who's asking about, from the German press agency, who's asking about solar radiation and whether we do expect further increase in the coming year. So I don't know if you want to take this one as well.
I don't know if I'm best placed to comment about that. In terms of aerosol loading, what we can expect is almost a stability. So what will be the key driver for solar energy going forward is cloudiness, and then it's really projections over Europe that will make a difference. So maybe Carlo, you can yourself better comment on that aspect.
Yeah. Maybe I can add on this point, and linking back to what Sam was saying before about the circulation playing such an important role over last summer in controlling water resources in that case, but the same circulation was one of the drivers for the increase in solar irradiance at ground. And so we do expect this sort of prominence of anticyclone over the summer, so a stronger anticyclonic condition over the summer is projected in the climate projection. So there is a signal that is consistent with what we are observing. Now, the contribution of the aerosol and the clouds somehow depends on the specific projection, but there is a broad alignment between observation and climate projections. So I jumped one question, and it was again from Martin Colemans, and he was picking up from Le Figaro on what is the main driver of why Europe is warming up in other continents. I think we answered that already, but I don't know, Sam, if you want to elaborate further on this.
Sure, I can do. So Europe is warming at about twice the global average rate, as Rebecca mentioned in her presentation. There are a number of reasons why this is occurring, and part of it is Arctic amplification. So the European area is predominantly land area. The land is warming up more quickly than the oceans across the globe. And then there are a lot of feedback mechanisms between the Arctic that is warming even more rapidly and the European area. And then, as previously mentioned, the particular atmospheric dynamics of the European region has meant that this warming has been amplified in more recent years. So if we look through the trends, the long-term trends of temperature change, although we see a steady increase of global temperatures, if we look back over the European records, it hasn't always as increased as rapidly as it has done in the last 10 to 20 years.
Thank you. There is another question from Georg Herring, and is about what do you think is the most severe consequence of warming for the people in Europe? And I guess this can take several strands, and looking at year by year, the impact has been different, and they've all been driven to some extent by the warming. But possibly for this year, the most remarkable impact, the most severe impact, has been the heat stress that Rebecca described and Samantha also responded to. So I would, unless Sam, you want to add, or Vincent, you want to elaborate further on this question, maybe we can go to the next. And I believe the presentation, as well as the reporting, will be made available to journalists. Okay, the next question, because we had a bit of a technical glitch, so I have questions coming on different directions. So the next one I have on my list is from Jonathan Tyrone from Bloomberg on drought, river discharge, and soil moisture. How are Copernicus products helping people to adapt? Can you tell us about some of the solution-oriented program and how they are designed to help adaptation?
Should I start with that one, or you, Carlo? So and I think there was a question earlier that asked about the type of data that C3S uses. So in terms of the type of data, sorry, there's some feedback coming from somewhere. In terms of the type of data that C3S uses, we use a huge range of data. So it's a combination of reanalysis, which is the latest numerical weather prediction, and coupled with data assimilation. That data assimilation comes from in situ observations from the atmosphere, from the ocean, from the land surface, in addition to satellite observations. So we are a satellite-based or a space-based program, so we leverage a lot of our data from satellites, and we make this all freely available through the Climate Data Store. And then in terms of the time period and resolution, so the majority of the data within the report is based on reanalysis. We have a global reanalysis product that goes back to 1950 that we've used in the report, and this is a 30-kilometer grid. So in situ data weather stations have been normalized and interpolated to a grid size of 30 kilometers, which is why there can sometimes be a differential between station data, which you may see from national meteorological agencies, versus the data that we release with the Copernicus Climate Change Service, because we have this large gridded product. And then in terms of the other part of the question of implications, they're really variable. So it really depends on where you are in Europe and what adaptation measures have already been taken place. But we know, of course, that near real-time availability of data is incredibly important to make decisions. And I think a really nice example from this is if we compare the heat stress and the heat waves that we had, that we've seen in recent years, so not only in 2022, but we also had significant heat waves over the summer in 2021 and 2019. If you look at the intensity of heat of those summers, they are far more significant than what we saw 20 years ago in the 2003 summer, which was kind of the first record-breaking summer for Europe. But the level of infrastructure and coherence between infrastructure means that many decision-making bodies are relying on climate data, not only from us, but from national meteorological agencies to take action on those decisions to protect vulnerable parts of society. So we can say absolutely that our data is used in decision-making to help make better decisions. And then we have a number of products that take our reanalysis products or take the future climate projections and they adapt them to particular sectoral requirements. So we have a number of applications that focus on renewable energy, that focus on insurance, that focus on water availability, and they ask specific questions relevant to that sector and release data available through the Climate Data Store specific to that sector. And all of this information is, of course, available on our website and through the Climate Data Store.
I just want to acknowledge what Nuria Lopez has put in the chat. Apologies for the fact that the glitches in the system has made me jump some of the question. I think now I have the correct list in front of me. So I will go through the remaining question in order as they appear in the document. And apologies for having missed some of those. I think the next one is from Damien Carrington from The Guardian. And I'd also like to know what we can expect in Europe in 2023 and 2024 with the return of El Niño. I guess I at least partially answered this question already, in the sense that the most noticeable impact of El Niño will be on the global mean temperature. The direct impact on Europe is weaker, so the teleconnection with Europe is weaker. And it's also important to keep in mind that the impact of a moderate El Niño or a strong El Niño over the European climate is different. So it's a bit early to judge what kind of impact we will see, because we need to understand whether we will have El Niño. Now it looks very likely, but it's not yet certain, and whether it will be a moderate or a strong El Niño. So it's too early to say. I think we answered the question from Anne-Laure Fremont from the Figaro on the way the data was collected. Some articulated on this point about satellite and model working in tandem and using the strength we have in both systems. The next question is from Bob Berwin, freelance Inside Climate News. Does the State of the Climate report mention the estimated 15,000 deaths linked with it? I didn't see anything in the summary. You didn't see anything in the summary because the report doesn't mention this figure. It's not something we report on in this report. It's a figure that does appear in other articles or in other media, but it's not part of the report. So the next one is again from Jonathan Tyron, Bloomberg. Could you also please clarify the statement on page 6 of the summary? The lack of precipitation persisted into summer, leading to critically dry soil. This, combined with the heat wave, further exacerbated the drought and its impact on vegetation. The dry condition may have, in return, contributed to the extreme high temperature. A further consequence of the dry condition was the spread and intensification of wildfire. Are you describing drought feedback loops that will exacerbate temperature ecosystem destruction? Can you please put this in plain language? Sam, do you want to take this one?
Perhaps if you start and then I'll complement.
Okay. I guess the question can be articulated in this way. We know that surface water plays an important role in controlling the extreme of temperature, because the transitional phase of water actually act as a dam on the extreme of temperature. So the lack of surface water, so the anomaly or the negative anomaly of wet soil humidity had likely an impact on the extreme temperature we have seen. So there is a feedback loop there, because the higher the temperature, the higher the evaporation, which may further exacerbate the situation. This has also a connection with wildfire, in the sense that wildfire depends on a number of factors, one of which is, at least at the first order, climate independent, and is the availability of fuel. So you need fuel to have fire. But once you have fuel, fire intensity and extent is to some extent controlled by weather. So this is not just humidity, it's also wind, it's also humidity, it's also temperature, but humidity plays a role there. So having very dry soil, which may mean also dry fuel, is a key ingredient there. So this is the connection I was referring to. We were referring to in the report. Sam, I don't know if you want to add to this, or Vincent-Henri.
Yeah, I think that was very comprehensive. And we also know as well that there are feedback loops with when you've had extreme drought, you're also more likely to get flash flooding because the ground is so hard and dry that instead of water, rain soaking into the ground, it runs off very quickly. So there's another feedback mechanism where you have very dry, very hard soils, then you are more likely to receive flash flooding when you do get that rain, if it is intense rain spells, because it can't soak into the top levels of the soil.
Thank you, Sam. The next question is from Bob Verwin from Inside Climate News. It says there is some data and research suggesting that a reduction of sulfurous aerosol may be part of what's driving accelerated and amplified warming over the northern hemisphere, mid-latitude, including Europe. Is there anything in the data you analyzed that speaks to this? Vincent-Henri?
Yes, the key word in this question is part. So as a scenario, having sulfurous aerosol being part of the relatively increased warming seen over Europe is a plausible scenario. The way it works is that sulfurous aerosol, for a part, are coming from gas phase emission from anthropogenic activities, and in combating air pollution, levels of sulfur dioxide, SO2, have been reduced, and as a result, the formation of aerosol from this SO2 has been decreasing. However, the situation is more complex because aerosol is not only composed of sulfur particles. Depending on the particles themselves, they can have a cooling or warming effect on climate. Sulfurous aerosol have a cooling effect, other aerosols have a neutral or warming effect, and overall, the role of all the aerosol is to go in the sense of cooling. So it's compensating to some extent the warming due to well-mixed greenhouse gases. So having a smaller contribution of sulfurous aerosol means that potentially there could be a bit less compensation of the warming and thus a bigger effect on Europe. However, what our data shows, based on the entire set of aerosols, so sulfurous aerosols are only one, there are other aerosols. When the soils are dry, for instance, there is more erosion and more aerosol coming into the air. And what we see actually is over the last 20 years, the effect of aerosol has become more negative globally. So we have the aerosol have been compensating or masking to some extent a bit more the effect of well-mixed greenhouse gases. So in short, for Europe, it's that the reduction of sulfurous aerosol could contribute to masking a bit less the forcing from greenhouse gases is a possibility. However, the full role of aerosol, unfortunately, does not go in this direction.
Thank you, Vincent-Henri. The next question is from the German National Public Radio and is about further elaboration on the reason why Europe has warmed faster than other part of the globe. And this actually is a question that we receive frequently, since we mentioned this high rate of warming for Europe. And as anything in the climate system, there are a number of reasons, and it's difficult to pinpoint to a single one. So that's the complexity of the climate system. But maybe if Sam allows me, to add on what she's already mentioned. I guess one additional driver that might be worth considering here in our response, something else that plays a role, is the loss of ice and snow on the mountain ridges all over the Mediterranean. So Rebecca in her presentation showed the 5 cubic meter of ice that we lost this year, and losing ice and losing snow. Again, we've seen a significant loss of snow days all over the continent. This makes the increase in temperature more noticeable. So it's not the only continent with mountains, not at all, but it's certainly an important element that is worth considering. The other element that I think is worth keeping in mind is that there are some fluctuation in these rates. And so it's not always been the case that Europe was warming faster. In the past, Europe was actually having a rate of warming that was more at pace with the rest of the world. So there is also overlapping with this driver that we mentioned. There is also an element of statistical sampling that needs to be considered. Sam, do you want to add anything more on this one?
No, I think it is frustrating when there's cumulative factors that add to the complexity of the situation. So as you mentioned, there was the loss of snow and ice from the Alps, albedo feedback, the large dry area in the Mediterranean. I think as well that perhaps there is a component of decadal variability that we're experiencing. And of course, it depends on where you define the boundaries as well. So if we do include Greenland in the European area, then as Greenland is in the Arctic, and the Arctic is warming much faster than other regions, then that also counts towards this high rate for Europe.
Thank you, Sam. That was a very important point to mention. Thank you very much. Unless we are facing another glitch, which I don't think, I think we cover all the questions that we have received so far. Anyway, the presentation and the recording will both be made available in the press resources pages and share with you. So you will be able to go back to what has been said and discussed this afternoon. Unless there are other pressing questions, I would like to thank you. Well, first of all, thank Vincent, Sam, and all the staff who made this event possible. And then thank you for attending this media briefing today. Have a good afternoon.